Okay, Shabab, good greetings to you. This is a short revision video. Please go through it and at the same time try to understand and write on a separate paper, finding answers. This is Semester 3 Science High-Q Revision Guide. So in your examination, you need a calculator. There's the calculator. You must know the periodic table of elements. This exam is based primarily on the periodic table of elements. Let's go straight away to the questions. I've ordered the questions according to the curriculum. So question 18, define the main features of the modern periodic table. This is the periodic table. So we said these columns going down, all these columns going down are groups. These are groups. I told you these are groups. The vertical columns going down. Group 1, group 2, group 3, this is group 9, this is group 13, group 17 and group 18. And going horizontal, flat like this. These are periods. Periods. So if I say group 2, period 4, you go to group 2, this is group 2, period 1, period 2, period 3, period 4. This is period 1, 2, 3, 4. This one. Which element is this? Calcium. It's in group 2 and period 4. You must know this. Then let's name the... You can see all these elements in green, all these ones. These are metals. The periodic table is divided into metals on the left-hand side, and the yellow, the elements in yellow, all these ones, they are non-metals. Non-metals. Then, these elements in green, in between, in other words, they have properties of both metals and non-metals. They are called metalloids, these ones. Metalloids. Metalloids. So, like I told you, metals are shiny, like zinc, they are shiny, they are malleable, you must know this. Non-metals, they are dull, they are brittle, something like that. You must know, this is based on the periodic table. Group 18 elements. I told you, group 18 elements are noble gases. Like helium, neon, argon, all these group 18 elements are noble gases. When we come to group 17, these are called what? Halogens. We can talk a lot of things on this periodic table. These are some of the features. Group 1, alkali metals. Alkali metals. So sodium is an alkali metal. Lithium is an alkali metal. Group 2 are alkali earth metals. Alkali earth metals. Now, let's take an element like aluminium, this one. They write it as Al. On top, you can see there is 13. Down, you have 27. The number on top is the atomic number. Down is the atomic mass or mass number. Atomic number, these are the protons, number of protons. And down, this is the mass number. To get mass number, you add the protons plus what? Neutrons. We will do this. So in short, this is what you need to know about the periodic table. Let's go to the next aspect. I'll come back to this one at the end. Number 1. Okay, let's discuss it. Demonstrates similarities and differences between atoms, between the atomic model of Democritus, Aristotle, and Dalton. So I have summarized here. These are the models. In other words, their ideas about the atom. Democritus, long time back, he said matter is made up of small particles which are called atoms, which are solid. Just solid particles which are called atom. This one you cannot divide. This is the smallest. Democritus' idea and Dalton's idea are agreeing. In other words, they are similar. Dalton also said matter, when you break down matter, you come to the smallest solid called an atom. This one you cannot divide it further. But Aristotle said no, matter cannot be divided into smaller particles. It's just continuous. And he said matter, all these things which we see, they are made up of earth, fire, and water. And air. 1, 2, 3, 4 things. Earth, fire, water, and air. These are the ideas of Aristotle. Right. So this is Democritus and Dalton. They were agreeing to say matter is made up of smaller solids which cannot be divided further. They are called atoms. And atoms are the same. For a given substance, the atoms are the same. And these atoms, for different elements or different materials, they will be different. These are the early ideas of the atom. We will look at the Bohr model. It is way different from these ones. Let's go to the next. So this is the same notes about Dalton, Democritus, and Aristotle. These are the notes. I took them from your book. This is question number 1. It will ask you about the early ideas about the atom. What did Democritus say? What did Aristotle say? What did Dalton say? Let's go to the next question. Question number 2. Explain why atoms are electrically neutral. Neutral means zero charge. Why are atoms having a zero charge? So here I have and describe the Bohr model of the hydrogen atom. Okay. So this is the Bohr model of an atom. Bohr said at the center we have the nucleus. So this is a nucleus. And inside the nucleus we find positively charged particles which are called protons. They are positively charged. How many are they? 1, 2, 3, 4. So there are 4 charges which are positive. So we have a +4 charge inside the nucleus, and around in the orbitals or in the energy levels. These are energy levels. We call this energy levels. That's where we find electrons. So electrons are negatively charged. How many are they? 1, 2, 3, 4. So -4. So this whole atom, what is the total charge of the atom? Because electrons and protons are always equal in number in an atom, the -4 + 4, the total charge will be equal to 0. So why are atoms electrically neutral? Because they have equal number of what? They have equal number of electrons and protons. Of protons and electrons, electrons. Protons are positively charged, electrons are negatively charged. So together they give you a net charge of 0, electrically neutral. So this is the Bohr model of an atom. Hydrogen has 1 electron, one proton. The mass number is 1. So hydrogen, the nucleus will have just one proton and 1 electron. Okay, remember the electron is massless, so hydrogen is written as hydrogen. Mass is 1, atomic number is 1. Inside the nucleus we have 1. So plus 1 and minus 1 equal to 0. Again, it's electrically neutral. Let's come to this table. Protons, what is the charge of a proton? We said it's positive. Neutron, it's neutral, 0. Electron, it's negative. Location, it means where do we find this proton? You can see the proton here, it's inside the nucleus. Same, the neutron is found inside the nucleus. Electrons are found in, look, these are the electrons. They are found in energy levels. In energy levels. This is what you need to know about question 2 and 10. Let's go to the next question. Question number 3. Define a neutron. So neutron from 0 charge. This particle, when we say subatomic particle, it means a small piece of an atom. So this neutron has a mass equivalent to that of a proton, but its charge is 0. So it has no charge. And a neutron has no charge. Electron, remember, electron is negative, minus. Proton is positive or plus. Calculate for a neutral atom given the mass number. If you are given the mass number and atomic number, the number of subatomic particles, we did this. Okay. So we said here, mass number, to get mass number, you must add the protons and what? Neutrons. We will do more activities on this. Atomic number is the total number of what? I told you here, atomic number is the total number of protons. Protons, let me increase the font for this one. Protons. Okay. Uncharged particles are there. So which one of the 3, electron, proton, or neutron, is uncharged? Obviously is the neutron. Mass number, how do we get mass number? Is the sum of protons. You add the protons and the neutrons to get mass number. You will see what we mean here. Okay? So here is the activity now. Like I said, on the periodic table, let's start with this one. This is an element. Let me see if I'm recording. Yes. This is the element lead Pb. On top, when we write it like this, Pb, on top is the atomic number, 82. The smaller number is the atomic number, which is the number of protons. Down is the mass number. Here they give us 200 what? Is it 207 or what? I'm not seeing clearly. Let me zoom. 207, yes. 207. So atomic number is 82. How many protons? Protons is the atomic number. Atomic number is the number of protons, so it's 82. Electrons, because the atom is neutral, same number of protons and neutrons, so electrons are 82. Let's come to the mass number here. Mass number is the number down, the bigger number, 207 in this case. What number do we add to 82 to get? So protons plus neutrons give you mass number. So what is the mass here? We must minus 207 minus 82. We get what? 125. Okay. Complete for oxygen and for zinc. Let's do this for argon. Argon is 18 here and 40. Atomic number, the number on top, the number of protons is 18 here. Sorry. This is wrong column. We are doing for argon. So it's 18 here. Then electrons are equal to the protons, 18 also. Mass number is 40. How many neutrons? 40 minus 18, that's what? 22. Complete for this and these elements. And tell me in class, explain why isotopes have chemical properties, similar chemical properties. Chemical properties of an element are determined by electrons, not protons, not neutrons. It is the electrons which give chemical properties. So isotopes have different neutrons, but the electrons are the same. Hence, they have the same chemical properties. So isotopes have the same chemical properties because they have same number of electrons. Remember, it's electrons which give the chemical properties of an element. If it is flammable, if it reacts quickly or slowly, this is all determined by electrons. It is the what that determine the chemical properties. I told you is the electrons. It is the electrons that determine the chemical properties. Let's go to the next question. Number 6. Determine atomic number, mass number, and subatomic particles for different isotopes. For different what? Isotopes. Let's just look at this one. They will give you the percent. If they give you percentage composition, for example, here I have chlorine 35. The atomic number is 17. Sometimes they put it down. And chlorine 37. You can see the atomic number is 17. The atomic number, the same number of protons. But why is the mass different? Because they are different neutrons. So these are called isotopes. Isotopes have same number of what? Elements with the same number of protons, but different number of neutrons or a different mass, different atomic mass. So if you have chlorine 35, 75%, and the chlorine 37, 24.2%, how do we calculate the average? So it's 35 times its percentage, composition 75.8, plus the second isotope, chlorine 37 times its percentage, remember it's times 24.2, Percentage means all divided by what? By 100. You will get this. Do many many examples from your book. So if I have chlorine 17 and 37 and chlorine 35 and 17 is the atomic number. How many neutrons here? I have to subtract 37 minus 17. It's 20. Okay? So chlorine 37, you have 20 neutrons. What about chlorine 35? I have to, from 15, that's what, is it 15 minus 7? It's 18. You can see they have different neutrons, but the protons are the same. Let me put the atomic number on top. Atomic number is the same, but different what? Mass numbers. That's why we have 18 neutrons, 20 neutrons. These are called isotopes. Let's go to the next question. Define atomic mass unit. AMU, atomic mass unit, defined as 1/12 times the mass of a carbon atom of isotope 12. 1/12 of the mass of this isotope, carbon 12. So normally we don't put this complicated mathematics. We simply say 1 AMU. So a proton has 1 atomic mass unit. Neutron has 1 atomic mass unit. Electron is 0 mass. So we use the atomic mass unit AMU to define or to describe the mass of these particles. So proton is given 1 atomic mass unit, neutron 1, electron 0. Or sometimes they say 1/18, 1840, which is almost 0 point something. Charge of a proton is plus, neutron, I said 0, electron minus. Location, can you tell me? I told you. Where do we find a proton, a neutron, and an electron? Go back to the previous slide, this one. Okay, let's continue. We come to this one. Question number 12 of your Haeckel. You must be able to explain now electron configuration. Configuration means arrangement. Let me write the word configuration. Configuration means we are arranging these electrons around the nucleus. We are guided by Hund's rule and Aufbau principle. These two principles. Let's start with Aufbau's rule. At the center we have the nucleus. When atoms occupy energy levels, they start from the lowest. They occupy the energy levels from the lowest energy level or from the lowest orbital. And each orbital is filled with what? 2 electrons in opposite spin. So the first one, let's arrange for 13 electrons using the Aufbau principle. The first electron must come to the lowest energy level, up, the second one down. They are in the first energy level. 1s, how many electrons? 2. When this one is filled by 2, we go to the next energy level, which is number 2. Remember, we are arranging 13. The next electron come to 2s. We show it going up, electron number 3. The fourth one in the opposite spin. It's full, 2s2. We have how many electrons? 1, 2, 3, 4. Number 5, come to this one, this orbital. Number 6 to this orbital. Number 7 to this orbital. Why do we put 1, 1, 1? This is Hund's rule. To say electrons must occupy the first orbital, come here, the first electron come here. If we have 2, it comes here. If we have 3, 1, 2, 3. Electrons occupy the orbitals singly, or 1, 1. Singly first, before pairing. This is Hund's rule. Read, this is Hund's rule. Electrons occupy these orbitals singly first, 1, 1, 1. Single, 1. Singly first, before pairing. Remember, we are doing 13. 2, 4, 5, 6, 7. Number 8 is now pairing here. 1, 2, 3, 4, 5, 6, 7. 8 comes here. 9 is pairing here. 10 is pairing here. Okay? It's full. This is 2p6. 2, 4, 6 electrons. When it is full, we go up to the third level, 3s. How many come here? Remember, this is 10, 11 come here, 12 come here. 3s2 is full. We go up, 12, the 13th comes here, 2p1. Okay, Shabab? So we can write it like this, 1s2, 2s2, and 2p6. The next 3s2 and 3p1. How many electrons are there? 6, 7, 8, 9, 10, 11, 12, 13 electrons. So on top, these are the electrons. If we are to count the electrons, these are the electrons on top. And these are energy levels. Energy level number 1, energy level number 2, energy level number 3. You must know how to interpret this. Aufbau principle says electrons occupy the lowest energy level first. When filled, then they go up the next level. Hund's rule, when electrons occupy these orbitals, they occupy the orbitals singly first, 1, 1, 1 each, before pairing. Okay? That's Hund's rule. Let's go to the next question. So we are now applying Hund's rule. I think this is how it will be asked. You'll be wondering, how do they ask these two rules? Which example shows violation? It means not correct. Violation means wrong. Violation, wrong according to Hund's rule. Hund's rule, it says electrons occupy orbitals singly first before pairing. This is Aufbau. This is Aufbau rule, which was violated because the lowest energy level must be full. This is Aufbau. We come here. This is correct. This is okay. We come here. This is now Hund's rule. This is wrong because of Hund's rule, which says here we need 1 electron and the next one must come here. Not for the 2 to come in 1 orbital before occupying all this. This is correct. Okay? Which of the following is written correctly? Which one is correct? Tell me. Only one is correct, or maybe there are two. That's how we apply the Aufbau and Hund's rule. We go to the next. An aluminum atom would have which electron configuration or arrangement? Configuration means arrangement. Arrangement of electrons. Look, aluminium is 13 electrons and 29. So you count which one has 13 electrons. We count these are the electrons on top. 6, 8, 10, 12. Here they are 12. And here, how many electrons? 6, 8, 10, 11, 12, 13. Yes, this one, B. How many electrons are here? 6, 8, 16, 17, 18, 19, 20. 20 electrons here. How many are they? 6, 8, 10. Okay? So here it's 10 electrons. 10 electrons. Here 13 electrons. This is the aluminium. Aluminium has 13 electrons. The atomic number is 13. So this one 6, 8, 10, 12. This 6, 8, 18, 20, 22, 8, 16, 17, 18, 18 here. We must be able to count the electrons. That's why I said bring calculator. Let's go to the next. Answer this one. Give me the answer for this one. I put this question for practice. For you to practice Aufbau and Hund's rule. Because your examination asks you to know Hund's rule and Aufbau principle. Let's go to the next question. Number 13. We are almost there. Calculate the number of representative particle present in a given moles of elements, atomic molecules, or compounds, and vice versa. Okay. So here, look, N is the number of particles in 1 mole. 1 mole of particle, 1 mole. Here you will need a calculator. Here's how many particles? 6.02 times 10 to the power 23. 1 mole of a substance. It has this number of particles. Which one is? So if there are 2 moles, you multiply 2 moles, it will be 2 times this 6 times 6.02 times 10 to the power 23 particles. How many are they? If there are 3 moles, so it's number of particles times number of moles. If they are asking you to find moles, number of moles equal to given mass divided by the molar mass. Molar mass. Let me say oxygen is O2. O2. When you go to the periodic table, let's go to the periodic table. Periodic table of elements. Let's go to oxygen. Oxygen is 16. Look at the mass of oxygen, 16. Okay? 1 mole of oxygen is 16. Let's go to our question. Let's go to the question. We are here. So O2, what is the mass? What is the molar mass of O2? It's 16 plus 16. 16 plus 16, which is equals to 32 grams. This is 1 mole. So if we have, so molar mass of oxygen will be 16. Let's say 16 here. Let's say you have, let's say 64 grams. This is the mass. Divided by the molar mass is 32. Sorry, molar mass is 32. Why do we say 32? Each oxygen is 16, but there are 2 of them. 16 plus 16, 32. So how many moles are they? 2 moles. Just know this simple calculation. We will do more practice in class around this, the use of this formula. Number of moles equal to given mass divided by the molar mass. Write electron configuration, noble gas notation, and different elements. Configuration, I told you, it means arrangement. Using the noble gas notation for different elements. Remember, these are the noble gases. Helium has how many electrons? It's 2. Neon has how many electrons? Check the number on top there. The atomic number is 10 electrons. Argon has how many electrons? 18. Okay? So we come to this. How many electrons are here? Neon has how many? He has 10. So inside here we have 10 already. 10 electrons. Plus how many in the 3s? 1. 10 plus 1. How many electrons? 1. This is the number of electrons from the noble gas notation. This is called the noble gas notation. Neon is a noble gas representing 10 electrons plus how many more electrons after neon? 1. 11 electrons. Let's come to this one. This noble gas, argon, has how many electrons? Argon is 18. Plus how many electrons? 1 in the 4s. So how many electrons here? 19. We can start from the electron configuration, the Aufbau notation, going back to the noble gas notation. Okay? Let's see here. 1s2, 2s2, 2p6, 3s2. How many electrons are there? 6, 8, 10, 11. We have 11 what? 11 electrons. So which noble gas is close to 11? It's neon. So instead of writing neon, yes, how many? 10. So all this, instead of writing all this, I will write neon. 6, 8, 10. There are 12, sorry, there are 12 electrons. Instead of writing all this, I will write neon. Neon represents how many electrons? 10. And after neon, I have 3s. This is noble gas notation. Let's come to this one. The rest you will do on your own. Let's come to this one. First, let's count how many electrons. 1, 3, plus the 10 is 13. Here is 13 electrons. Let me cross check. 6, 8, 10, 11, 12, 13. Yes. So 13, I cannot take argon because 18, argon is 18. Which noble gas is close to 13? It's neon. So this one I will write it as neon. Neon takes how many electrons? 10. So this is neon. 2, 4, 10 here. Up to here, it's neon. After neon, I have 3s2 and 3p1. Okay? Do like this. Let's write the for practice. We have an element x with 20, with the atomic number 20. Let's write the noble gas notation of this one. Okay? We write. We start with the half bow. 1s2, 2s2, 2p6, then 3s2, 3p6. How many electrons are there? 6, 8, 18. Okay? Then next, 4s what? 4s2. How many electrons? 20. We go back to the periodic table. Which one is close to 20? It's argon with 18. So instead of writing all this long arrangement, I will take 18 electrons. 2, 4, 10, 11, 12, 18 up to here. All this, it's argon. So I will write argon. After argon, I have 4s what? This is the noble gas notation. This one. Noble gas notation of this element. Ask in class, we can clarify further. Give me the noble gas notation of these ones. And show me in class. Let's go to number 20. Explore the location of an element in the periodic table based on their electron configuration and predict their chemical and physical properties. Chemical and physical what? Properties. Let's come to this one. Let's go to the, you must know what we call the valence. Valence gives you the group number. What is valence? The outside electrons. Outside or outer side, outermost electrons. The outside what? Electrons. Just focus on the outside electrons only. Let's look at this one. This is argon, and how many levels? Level number 3. It means this is period 3. This means this element is in period 3. This. Now, what is the valence now? What is the valence here? Sorry for this. It's 5 plus 2, 7. But because there is a P, so I add what? 10. The group is 17. Group 17. So this element is in group 17, period number 3. If there is an S and P in the last level, you add 10. Like this one, we have to add 10. What is the period? Period number 2. This one is period 2. Because the last level is 2. What about the valence? Valence electrons, 4 plus 2, 6. To get the group, I add 10, 6 plus 10, group 16. So if I say period 2, group 16, when I go to the periodic table, let me go to the periodic table, group 2, group 16, period 2. Like here, I come here, this is group 16, period 1, 2. Which element is this? This is oxygen with how many electrons? 8. That's how we locate. That's the location of this atom, of this element. Let's continue. Okay, come to this one. This is period 4, group, because there's no P. The valence is 2, so the group is also 2, group 2. This element is in period 4 and group 2. Let's come to this one. Only focus on the last orbital. How many levels do we have here? N is equals to 1. Let me use this one. Level number 1, N is equals to 2, and N is equals to what? 3. The levels are the periods. So this atom is in period 4. Group. The group and valence is the same. Let's count how many electrons are there. 1, 2, 3, 4. Group 4. Because the electrons in the outside shell is what? 4. There are 4 electrons. The valence is 4. 1, 2, 3, 4. Group 4, period 4. Let's go to the next question. So we will practice with this one. Complete here. Here you are putting the configuration, the half bow. Here you are putting the noble gas notation. Noble gas notation. Follow what we have been doing to complete this and show me. Okay? In class. On this one. Let's go to the next question. Determine the valence electrons in these atoms and put it on the dot structure. Determine the number of valence. Valence are the last electrons, I told you, or the outermost electrons, the last electrons, or the outermost electrons. So let's go to this one. Outermost. Okay. I shifted this. Let's come to this one. The outside shell is number 3. So how many electrons are there? It's a 1. Only 1. So what is the dot structure? When we do the dot structure, the electron dot structure, you only write the symbol, it's sodium. How many electrons? We show the outside electrons only. We don't show the inside electrons. So how many electrons outside? It's 1. Let's come to magnesium. So it's Mg. This is the last. How many electrons are there? 2. You can put 1, 2. We are only showing the outside electrons. Aluminium. How many electrons in the outside shell? It's 2 plus 1, 3. So we write it as aluminium and 1, 2, 3. This is the dot structure because the dots are showing the electrons in the outside or outermost shell. Complete this one and show me again in class. Let's go to the next question. So this is the valence. That's about valence valence electrons, the outside or outermost electrons. Okay, coming to this one, explain properties. Explain properties of the elements in the same group. So elements in the same group have the same number of electrons, I told you. All these elements in group 1, they have 1 electron. Same number of what? Electrons. Elements in the same group have the same number of valence electrons. Valence. Elements in group 2, they have 2 electrons outside the shell. 17, the 7. All these electrons have, all these elements or all these atoms have 7 electrons in the outermost shell. So elements in the same group have the same number of valence what? Electrons. Which element has different chemical properties from the others? Remember, it's electrons which determine the chemical properties. So here, check. Elements in the same group have the same what? Chemical properties, because they have the same valence electrons. Let's come here. Fluorine, where is fluorine? F. The next one, helium. Helium is in group 18. This is group 18. Fluorine is in group 17. Let me use a different ink. So fluorine is group 17. Helium is group 18. Chlorine is this one, group 17. Bromine, Br, is group 17 again. So all these in group 17 have the same chemical properties. So this one is in a different group. It has different what? Chemical properties. Understand this kind of question. We come to this one. Explain the periodic trend. Trend means a pattern. Pattern in atomic radius of across a period. Period, it means from here to there. This is a period. And down a group. When we go down, going down. This is going down a group. We are going down a group. This is the atomic radius. It means how big from the center to the circumference. This is radius, atomic radius. Look, down the group, the atoms are getting bigger. Down the group. Across the period, from left to right, they are getting smaller. So the biggest atom is what? Which one? This one is the one down here. Can you check which one is this? CS. I'm seeing here it's written CS. Okay. CS, this one. Then with radius, what is the radius? This number 2.65. Is it 2.65? Can you check? Let me zoom it. So these numbers are showing the atomic radius. 265, the radius is in units, in a given number of units, 265. 265. Then we come here. The smallest is to the right, which is this one, helium. This helium. The element in group 15, period 3. Let's go to group 15. 15. This is 14, 15. Period 1, 2, 3. This one. What is the name there? Let me zoom it. P, phosphorus. So you must be able to use the periodic table. It's phosphorus. Atomic radius of this atom, check the number again, like that. So finish. So atomic radius, when we go across the period, it decreases. Down the period, it increases. Across a period, it decreases. Getting smaller. Down a group, the atomic radius gets bigger, increases. I think you can see when we go down, the radius is increasing. Let's go to number 22. We are almost finishing. The periodic trend, electronegativity. Across the period and down the group. Again, you should be able to take the numbers from the chart. This is showing the electronegativities. Look, the electronegativity here on the left for this period, 2.2, and here 3. So it is increasing across the period. It increases. Down the group, it decreases. The measure of attracting electrons is electronegativity. The power of attracting electrons. Down the group, what is happening? These numbers are getting less and less. The power of attracting electrons decreases. Across the period. So these electrons, this electronegativity is increasing across the period from left to right. Increases. Look here, we have two atoms, hydrogen and fluorine. This is hydrogen on the left and fluorine on the right. Hydrogen fluoride. Which one has more higher electronegativity? It's fluorine. So in this hydrogen fluoride bond, which one is more electronegative? Fluorine. It has a high electronegativity. It will pull electrons to itself more than what? The hydrogen atom. Just know this. You will be given those numbers of electronegativity. Choose which one has a higher electronegativity. Number 23. Explain trend in ionization energy across a period. Across the period. So, from hydrogen to helium, this is period 1. From lithium to neon, this is period 2. From sodium to argon, this is period 3. First ionization energy. Look, so across the period, the ionization energy is what? Is increasing. Ionization across the period, it increases. What is ionization energy? The energy needed to remove one electron, to take it off. The first electron, first ionization energy. If you take the next electron, second ionization energy, and third ionization energy. So this trend, look at the pattern, across the period from left to the right. From lithium to neon. Check on the periodic table. the electronegativity is increasing across the period. But down the group, lithium, neon, and sodium and potassium. This is same group. It's getting less and less. So in the group, between groups, it decreases. But across the period, it's increasing. Okay? You must be able to interpret this graph. Completed this. We did this early effectivity. Show me in class. Show me as well. Get the answer here from electronegativity. Show me in class. Show me the answer. Difference in size between atom, ion, and anion. Okay. Let's start with the atom. Remember, we were saying the atom has same number of electrons and protons. It's neutral. If it loses, let's start with this atom. If it loses, it means minus 2 electrons, for example. If it loses 2 electrons, it forms a positive ion, which is smaller. You can see positive ion is smaller. The positive ion is the one which they call cation. Cation. A cation is smaller than the atom. If it gains plus some electrons, let's say plus 2 electrons, the atom is negatively charged. It's bigger than the atom, and it's negative. A negatively charged ion is called an anion. So anion is bigger than the atom. If the atom loses electrons, they form a, so it's there. They form a, if it loses, they form a cation, which is positive. They form a positively charged, so it's positively charged atom. Because it loses the minus, so it forms a positively charged ion called cation. Which one is bigger? Anion. Anion. Or anion is bigger, and a cation is smaller than the atom. You can see here the cation is smaller. The anion is now bigger than the atom. Okay? Like this. So understand this question 24. Let's go to the next. We are left with 3 questions on radioactivity. Radiation, investigate radiation, illustrating characteristics of alpha. Alpha is positive. Beta, the electrons, the negatively charged. And gamma, remember the rays are 0 charged. In terms of mass, ability to penetrate, and impact on humans. Impact, do they damage more or less? Let's come here. Beta are minus, negatively charged particles. Alpha are positively charged particles. Atoms break down in order to gain stability, and they give us these three radioactive particles, which are alpha, beta, and gamma. Let's start with firing. We are now firing the three. Alpha, it's 2+. Beta, it's an electron which is minus. Gamma, not charged, 0. Remember, plus or in where do I write? Positively charged, positive charges. How do I compress this? I need my pen. It's not writing, okay. Positive charges attract negative is attracted to the negative terminal. So alpha is positive. Look, the plus will come to the minus. So that's why the alpha come here. So this is alpha. And beta, which is negative, it is attracted by the positive charge. So beta goes to the plus, which are electrons, and there is negative. Gamma, because they are not charged, they are neutral. It goes straight. So this is gamma. Beta goes to the minus, alpha. Alpha comes here. Okay? Let's complete here. Particle, beta, which is an electron. They are very small. So because they are very small, if you are hit by a small particle, the damage is low. Alpha, the mass is 4 times. So the damage is very high. Okay? Gamma, they are rays, very, very low. So if we put this low, this one we can say it's medium. Okay? We'll say medium or average. The damage is medium. But when you throw this, which one will go far? The light, the radiation penetrates or goes a longer distance. It's like light. So the penetration is high. These ones which are very high, they don't go far. In other words, this is low because it's very heavy. This one, electron, is medium because of its size. The alpha particle will not go far. It quickly stops. Okay? But the damage is very high. Maybe the last question. Okay? Spontaneous radioactive decay with characteristics of and the charge accompanied in terms of what? In terms of atomic and mass number. Okay. So we said radioactive particles which are very big, they break down in order to become stable. They are very unstable, so they break down. In the process, when they break down, they give us 3 radioactive particles, alpha, beta, and gamma. You must know that alpha are helium particles with a mass of 4, atomic number 2. Beta are electrons, mass is 0, atomic number is -1. Okay? Gamma, the mass is 0. This is light. It's radiation. We say gamma rays, like light. 0 mass. Okay? Let's go now to balancing chemical equations. Radioactive particles. This one is unstable. It's very big. Big and unstable. It has to break down to form the smaller, which is stable, smaller particle, and this one is the radioactive particle. Helium is an alpha. But the mass on top to the left, mass on the left side must be equal to the total mass on what? Right hand side. What do I mean? Here is 226. To the right I have 4. What number do I need here to balance the 226? I need the mass number here is 220 what? 2. 222 plus 220 plus 4, 226, balancing with the 226 on the right. Okay? Let's come here, 80, 88. The atomic number 88 on the left. To the right I have 86 plus 2, 86. So it's balanced now. Let's balance here. The mass on the left is 230. To the right is 230. So the mass here is 0. 91, it's minus 1 here. So what is the atomic number here which balance 91? I have 91 here. I need 91. Minus 1 plus what? 92 equal to 91. So here it's 92. Can you complete number 3 and number 4 and show me in class? Okay. Shabab, thank you so much. I have put these activities here for your practice. We will continue to practice day before the exam. Inshallah, you will do well. If there is any question, let me know. Assalamu alaikum.